Welcome, everyone. This is my dad. His name is Todd, and he basically taught me everything that I know about computers and CGI. If I have the video ready in time, we may be posting this near Father's Day. So happy early Father's Day to you, Dad, and to any fathers in the audience. So the reason that I had the idea for this video topic of the history of CGI and like how you got into CGI and then shared CGI with me was because actually I think I might have been sitting in the same room that you're in right now, and I was on the YouTube channel Modern Day Debate. Moon landing deniers often say, "Oh, Apollo just used movie special effects." So I remember putting together a demo reel of what Hollywood's cutting edge special effects looked like in 1969 or around those years. I made a passing comment in relation to that. I've spent my life studying visual effects. This is the career I wanted to be in. And then later on, there was a super chat.
Kango44 says, can I ask Peter if he worked on any shows doing CGI?
Oh, no, nothing like that. I mean, and so I realized this was a little bit more complicated to explain, like why I have this background knowledge about CGI. That led to the idea for this video topic. So I really appreciate you being here, Dad. Maybe a summary of your career first?
My career started out more on the hardware side. My first job was at Digital Equipment Corporation.
When was this roughly?
In 1981, 82. My original job with Digital Equipment Corporation was more servicing hardware. I was repairing computers that cost even in the tens of thousands of dollars for the computer system. If you spilled your drink in your keyboard, then I would hand you a bill for like $2,000 to replace the keyboard.
Oh, man.
They weren't really in the homes yet. Right. Most everything was universities and businesses. The computer hardware career path was gradually dying. And the primary reason for that was that large-scale integration was shrinking the entire computer onto a single chip. And the more and more that happened, the more and more disposable it was.
Right. Parts
that you couldn't really service very well. You just like replaced it if it broke. While I was working at Digital, I was moonlighting, working for the computer animation company. The reason I did that was more to get my hands on working on the software side. I probably went out on a service call to service a computer for Datatech Images.
Oh.
And struck up a friendship with the owner of the company.
What year was this?
So 83, 84. The owner was more an artist. He got his degree at OSU in working in the computer graphics department. The open source licensing stuff did not exist back then. If there was a federal grant, then all of the results of the project were in the public domain. Steve had gotten tapes of all of their software. My first task was to take the software that we got from OSU and actually port it to our computer. We started out using a Microvax computer. I mean, I had to write the device driver for the frame buffer, and I had to write the libraries and interface to match up with, you know, our frame buffer, replacing the custom hardware that OSU hand wired from students in the electronics department that didn't even have documentation. A frame buffer is like an array of memory that can be converted into an NTSC video signal that can be put on a display. So what I did was I created a program using SDL that is just represents a simple frame buffer. And when I run that, It just opens a little window. This represents the frame buffer hardware. We had a bunch of different ways to render the data. There was like poly-Z sort and my ray tracing program, which is called Planar.
Now, am I correct that at this time, at least in this line of work, we are very strictly talking about pre-rendered graphics? This is not the market that led into video games. This is the market that led into Pixar movies.
Well, there were no real-time computer graphics back then. It could take minutes to display one frame.
Right. So this was a heavy
if it was
process.
A very complicated image, it might take hours.
Yeah.
And it's a 16-bit processor. So there were rounding errors when you were trying to render an image. And those rounding errors would sometimes screw it up.
Yeah.
So it wasn't unusual to have somebody watching the render. They would hire somebody on third shift. And when they saw something on the screen that was a big mistake, they would make a phone call and page out a software developer to come and fix it.
I am intimately familiar with that problem of needing to sit there and watch a render, possibly in terror, depending on the situation. The one part of that I'm not familiar with is needing to make a phone call if you need to change something.
Some of the software that I wrote, it was with an eye to the future because I knew that we would eventually be able to put it on faster processors. And it was completely unrealistic commercially to try to render an image where it took a week to do one frame. But I finished that software anyway because I thought it was cool and I was interested in it. Doing ray tracing, that was the big cutting edge deal with all the special effects you could do with that. I don't think it ever really got commercially used in any project. The company died before it could be used. I'm going to reset the frame buffer back to black. Okay, so now the frame buffer is in its original state. So if I do the scene assembler, I can pipe this same scene script in as if I typed it. You know, standard input, just pipe it in. And then it pulls it up. Now, from this point, we can add more objects to it. What I wanted to do was to create one of these scenes that involved two mirrors reflecting towards each other.
Oh, right.
And that resulted in this final test. And this adds yet another.
Okay, this might be the one that you showed me.
Yeah, this is another level of difficulty for the Raytracer. You can see this image bouncing back and forth between the mirrored ball and the mirror.
Yeah, so that particular area of the image is going to probably take longer to render, right?
Oh, yeah, this in the original VAX, this image took like 4 days to render.
It looks like something is causing odd-numbered reflections to see the sky sphere as red instead of blue. I wonder if that's like a software bug.
This never went into production.
Okay.
And I never got past this point.
You wrote this planar Raytracer all on your own, basically? Just following their architecture?
One of the complexities was that I was trying to render an image at 640 by 480. But with ray tracing, there was no way to do I'm forgetting the word.
Anti-aliasing?
The anti-aliasing. There was no way to
Did I just read your
anti-alias.
mind?
Yeah, you did. There was no way to anti-alias that pixel, that ray, without having in between pixels.
I get the impression that you were not like solving the mathematics of the light geometry. You were just implementing it. Is that right? Did you get the mathematics from like papers at OSU or
No,
something?
no. I had books that I got from SIGGRAPH, and I found all kinds of different conflicting approaches. Hardly any of them were doing ray tracing because it was really outside of the realm of what the hardware was capable of. I was pushing the edge. So, I mean, I had my college math books out and figuring out the basic math to do ray tracing from scratch.
Wow.
I did not
Okay, so
have I did not have an example to follow.
but did you have like, I mean, at least for example, oh, like equations for a ray intersecting with a plane or
No,
something, right? You you
no.
you were solving that
Okay.
geometry yourself?
Yes.
Oh my gosh. You
Well,
wrote your own ray tracer from the ground up. How much time do you think you spent writing this code?
I spent months,
What year do you think this was?
87, 88.
But there is earlier work that you were involved with from Data Tech Images, isn't there?
Oh, sure. I mean, my planar program was the last thing I did for working in that environment.
Okay. So do you want to get into any of the Data Tech Images demo stuff? There was the beta tapes that you had in your garage, and we had no way to play them. And of course, I remember like specific things that you were telling about, like the Rock Stack toy and the heart animation, but I had never seen them like my whole life until like 6 months ago or whenever you recovered that beta tape.
Yeah. I mean, this was a demo reel that we made that so Steve could use it to sell projects. We recovered this off of an old videotape, so it's pretty glitchy.
Now I notice it looks like this is not using any type of ray tracing because I don't see any shadows being cast by those.
Do you know how he did reflections?
I
This
was
is
going to
using
ask if he inverted the objects and duplicated them. I was going to ask
he
that.
did. He
Okay.
absolutely did. And see, this object was rendered using poly Z sort.
That's what I was
So it
asking.
was
Yes.
certainly not capable of doing real reflections. What else have we got?
It seems like there was a rich tradition almost of modeling chess boards in early CGI, wouldn't you say?
Yeah, because it was a great subject. The chess pieces were easy to create in 3D models.
It kind of made me think of this Pixar short called Jerry's Game.
Yep.
So there's your and Steve's image from Data Tech Images, and then 10 years later was Jerry's Game from Pixar. So in all that time, apparently chessboards remained strong in CGI culture or whatever. But I just thought that pairing was fun.
Yeah.
I'm sure that you have some more Data Tech Images demo reel stuff.
Well, we have the heart one. That was a big project. Here it is.
Catheterization laboratory. In the interest of safeguarding your health, your doctor has recommended that you have a cardiac catheterization performed. The heart functions as a series of pumps which supply blood and oxygen to the entire body. There are actually 4 separate chambers. The 2 upper chambers receive blood, and the 2 lower chambers pump the blood forward. The chambers of the right side of the heart receive blood from the entire body and pump it to the lungs, where it receives oxygen. The normally smooth interior of these blood vessels can gradually become blocked, either partially or totally, by deposits of cholesterol that build up over the years. The first method involves the use of the artery in the arm and requires a small incision just above the crease found at the level of the elbow. Once the catheter enters the bloodstream, it is carefully guided toward the heart with the aid of X-ray equipment called fluoroscopy. We hope this film has been helpful to you and will make your experience more relaxed and more comfortable. Remember, our goal is to make your stay at Riverside Methodist Hospital as safe and comfortable an experience as possible.
This heart animation, first, the shape of this object is fairly complex.
Yeah.
So what he did as an artist was he modeled the entire heart out of clay. And then he took a cheese slicer and sliced the entire model. Each layer was then laid on our digitizing tablet, and he would use the puck to go around the edges and plot points, then create a list of connecting the points into polygons with all the vertices.
I remember you describing that process to me at one point when I was a kid. I hope that there are some patients out there who benefited from that video, because that looks like a terrifying procedure that they were going to face.
Well, I don't know how long the hospital used that video, but I imagine it might have been more than a decade. I'm sure it benefited a whole bunch of people. One of the other animations that I did testing the software, making sure it worked, was the one with the child's toy, which now, by this time I had my first child. What I did was I modeled one of his toys as
you
a
can
candidate.
probably use his name, because I'm going to have to be mentioning Alex a lot in my part of the story.
Yeah, it's Alex, my firstborn. Here it is.
Yeah, there you go. And this is, I can tell this is Poly Z sort, not planar, because there's no shadows.
Yeah. No, this predated planar. What I was working on was something called Twix. It was software that we did get from OSU. But the thing is that the software was an interface to a huge piece of hardware. And early stuff, we did not have that piece of hardware. Steve managed to find out that the computer graphics department was retiring the Evans and Sutherland machine that was required for Twixt. And they sent it to the scrap. And he went over to OSU and put a bid on it and bought it.
Oh.
I had to figure out how to interface the Twixt on a new computer to the Evans and Sutherland. It had a computer engine that was designed to calculate vector graphics in three-dimensional space, all wireframe, in real time.
Whoa.
Now, we couldn't do that with rendered images. I could assign a knob to Z position. And when I turned the knob, all the objects would move in the Z axis back and forth. You could move the objects around and save to the computer, and then move the objects and save the computer.
Do you remember if you'd have to position the object for each frame like stop motion animation, or if you could skip frames and let it interpolate?
It did interpolate. We had to have the transformation for each frame.
Okay, so no keyframing then. This was basically digital stop motion.
Yeah, basically.
Since we were talking about the Rockastack toys, by the way, I had to look up that's what they were called. Yeah, there's a Wikipedia article on them. Some of my international viewers on YouTube may have never heard of this. Apparently, they were not popular in Australia, for example. Since we were talking about yours that you made for Data Tech Images, I also thought of this Pixar short.
Oh, yeah.
So then I also made this fun little side-by-side comparison. And once again, you did yours first.
Yeah, well, Pixar's animation includes a lot more than just that stacking toy.
Do you want to show any of the, was it the DG11 software?
Okay, so here is an example of DG11. It would grab the frame buffer, and this was an example of where there's a pointer that we would use with a graphics tablet, not a mouse. So we would start off like creating a two-dimensional object.
Making a wine glass?
Okay, yeah. Now I can accept that, and I can then make it 3D by revolving it. And I need to choose a path. I gotta remember how to do this. I'm going to make the path a circle, and number of points. Oh, let's do 16, maybe, like that. We can accept that and then perform the rotation, and then basically accept that, and then we get the polygons.
I have a dim memory of you showing me something like this when I was a kid. You said you found this hard drive in the bottom of a computer case?
Yeah.
This was stuff that I was convinced was gone forever. When you finally recovered it, and I opened the zip file that you gave me, look at that timestamp. Do you see that?
Yep. I had this really bad habit of getting to a point where I decided to upgrade a computer, and I squirreled the disk drives away.
The stuff was like basically back from the dead for me. It was amazing. Chronologically, there's kind of two groupings. There's some really early stuff from when I was literally 7 years old, the year 2000. I suspect that what happened here was that you decided I was old enough for you to teach me about POV-Ray. There's evidence, like you telling me some stories about your CGI, because look at what one of the earliest scenes was.
Oh, yeah.
This was my Rock-a-Stack toy at age 7. Now, of course, I don't think I had a Rock-a-Stack toy that I was looking at as a reference when I made this. This was from memory.
We were homeschooling you kids, right? All of you. And a key part of homeschooling is to get to know the individual child. It was on my list to get you involved in programming computers, but you were so art heavy in your interests that POV-Ray was like the ideal tool to get you hooked. The trick worked. It didn't even involve a lot of effort on my part. All I had to do was introduce you and show you the basics.
This is supposed to be a mountain. That's all I have is those two scenes from 2000. And then there's like nothing for 3 more years. The next thing that I remember, this must have been around when I was 10 years old. I have a specific memory of us being in COSI, Center of Science and Industry. Here we go. Yeah. I remember there being like a kiosk. They had taken that concept that you were showing off in the DG11 software, where you can draw a spline and revolve it around an axis, but they had basically branded it as, oh, you can make a Christmas ornament. This was no doubt like leading up toward the Christmas season. And so I got embroiled in like creating a Christmas ornament. You guys wanted to go home. And I was like, no, I'm not finished yet. But I in my memory, you kind of appealed to me with the promise of like, oh, I have something better that I can show you at home. So I think you took me home and showed me some more CGI related things. But somehow that led into conversations about POV-Ray. And that, I think, was what rekindled my interest in it. This is an early scene I created, but this is like me exploring more like pictorial possibilities with POV-Ray. And I remembered this little musical jingle that would play when a render was finished. And 20 years later, I could still hum the tune accurately. I was surprised to learn this, but it's still being used as the render finish chime on the Windows version of POV-Ray. This is like a reconstruction of what it may have looked like while I was working with POV-Ray on our desktop all those years ago.
Yep. That's real familiar.
Let me go through some more POV-Ray scenes that we recovered. This is supposed to be K9 from Doctor Who. There's a random necklace. I was probably learning how to type in colors with this one.
Mm-hmm.
There's a ray gun, like some kind of a sci-fi ray gun. Here's another attempt at the Rock-a-Stack toy.
That's an improvement.
Yeah, but the reason I made this was obviously because you had told me you made one. And that led to me making this little second comparison. There's yours and there's mine.
Yep.
What is that, like 17 years later? Here's some more like of me learning shapes and colors. And at this point, I was like still getting a sense of how the coordinate system worked. There's a little cardboard box with a sphere in it. This one I called Chomp. This one, how do I explain this one? This was supposed to be a robot. I imagined these robots as characters for a game that we were playing. Okay, there's a little ice cream cone. That one must be mint flavored. I wrote my own name there. Here I got fancy and made a wooden crate with a sphere in it. This one I did not type by hand. We may have revisited the software you showed me with the DG11 where it was like creating a lathe object. I can't say for sure which software we used to export from your DG11 program to a POV-Ray scene, but I'm pretty sure that must have been what happened. Some type of pipeline was constructed there. This is a POV-Ray scene where I was learning about unions and origin points. So I had the grand ambition here of creating a character with limbs and joints that I could repose. I shared this on my social media recently around Easter. This was just a Easter themed POV-Ray scene I made.
Yeah.
Oh, and here's an even more ambitious jointed character with reposable joints. This one has fingers. And here we get to Pikachu Village. Pikachu Village, there's quite a story here. This was a scene that I started building in POV-Ray where I got kind of ambitious. Now, these are some modern renders where I took the old scene file and rendered it using a modern version of POV-Ray. But this was the scene that I created. There's a store. I was building an entire village. I was like, what's the scale of imagination that I can realize with this tool? There's some Pikachus using floaties in a pond near the village. There's some wearing hats. I think this was long before Detective Pikachu was a thing. I think they're just derby hats or something. Here's a render I made where I was intentionally trying to be more like authentic. So here's a little animation that I rendered of the scene where it's just the camera flying through. There's like kind of an entrance to the village through the wall that surrounds it. There's some birds flying in the sky, but obviously this wasn't animated, so like they're just frozen there. It's a static scene. Here's a scene, render I did of like flying in through one of the houses so you can see inside the house. It's kind of slow, but I just wanted to keep it nice and gentle. And there's an upstairs. Don't pay attention to the bed poking through the ceiling in the room below. There's a bed with a little table there, a cup of a glass of water, a cup of coffee, a plant in a pot. Starting to actually like build a fictional environment that had a feeling to it was, I think, another artistic leap for me in using CGI. Like, I especially remember the feeling of building that potted plant and putting it in the house and just like feeling like, this actually feels like a house now. This, by the way, this was March 2004 at this point. I was 11 years old. This is the scene file. These comments are as though I'm talking to a user. It's instructions. Change camera location / look at all you want. Don't go through anything you can't see through. So I'm imagining that there's going to be a user who's going to explore my Pikachu Village scene by editing my scene source code. Because, like, I had the window narrow, and you can see how, like, I put these double slashes over here, and then, like, pushed the text that I was writing to the user way far to the right. So I was like trying to artificially create this sort of separation between user functions and game dev content. You can tell, like, in this scene, I would expect things to sort of be hidden or non-obvious that like with my modern rendering skills I can make extremely obvious, like just by showing the scene better than I knew how to show it at the time. As nearly as I could recreate it, this is what it was like for me while I was creating the Pikachu Village. Go down, you're too far up. There we go. That's where you're supposed to be. There's a render. And then you can, like, edit the location.
Yep.
Edit, resave, re-render. That was the process. And for really difficult fine-tuning, you had to just go through that over and over.
For your age, that was still very creative.
Actually, Dad, I have a surprise for you. I'm gonna stop sharing my screen. Go to my website,
goodness.
petermarkley.com. So go to archive.
Okay. Yeah.
There's Pikachu Village. Okay, so there's a brief write-up about it, but if you scroll down just a little more, explore scene. There we go. Can you see the controls?
Oh my goodness.
You can hold that for continuous motion if you want. I think it also respects keyboard input, if that's more convenient.
I'm doing fine.
Now, there's no collision detection in this. This is just very
Oh,
simple.
I wouldn't expect collision detection.
Yeah, you can go straight through things if you're not like taking care.
Look at that.
Are you gonna buy a floaty? You found the pond with all the Pikachus swimming. In order to make that work, it basically vibe coded a non-feature complete POV-Ray scene parser in Python using the Blender Python API.
Wow.
So now I have a Blender copy of the POV-Ray scene.
Oh my goodness. That's wild.
I was like, okay, there is no way I'm going to be able to do this. Is there? And just like basically a day or two later, I had it working, making it explorable on my website. I don't think I could have ever dreamed. That's enough about Pikachu Village. Now, at this point, I actually remember Alex teaching me something. But I have this scene file here that was called sign_example. But I think what prompted this might have been, I was trying to make a series of renders where I was taking the camera around the outside of that cylindrical wall around the village. And it was like very tedious to like sort of iteratively guess where the edge of that circle was. And so Alex saw me doing this, or maybe I came to him with questions or something, and he explained to me, you could just use math to do this. I'm almost sure that either Alex wrote this for me, or these were basically my notes from Alex explaining it to me. He described how the sine and cosine functions look when they're plotted, and he described how they work together in two axes to create a circle. And I got it. This file is dated March 13th, 2004. I don't know how I learned this before I learned algebra, but I think I did. This is trigonometry. And that concept has stuck with me ever since. I never forgot that. I'm calling all of that Era 1, where I was on the shared Windows desktop with no user account of my own. There are later eras where I got my own user account on Linux, and eventually I had my own Mac. I'm calling those Era 1, Era 2, and Era 3. Let's move on to Era 2, my Linux desktop. This was, the distribution of Linux was Linspire. In this era, I leveled up some of my POV-Ray game here. Obviously, you know, here I was taking up the tradition of chessboards in CGI.
Yep.
Here I got a little bit artistic and abstract. Here I made something pictorial.
There you go.
This is a drawing, obviously, but this is one example that I have of a drawing that I also made in POV-Ray.
Oh, yeah.
I don't know for sure which one came first.
You storyboarded it, obviously.
Now this, let me explain. Alex had a friend, and the two of them together were basically writing this satirical Douglas Adams-esque novel, serial thing. He turned it into a book, which he actually self-published before the age of self-publishing on Amazon. He called it Malix and Ice Punk. He recruited me to do the artwork for it. This began a period of me collaborating with Alex. This character was named King Thub Thub. You might recognize my chessboard from earlier. which is, I think, the only POV-Ray that I contributed to this cover image. Obviously, I made the drawings. I was like very unskilled at this point with figure drawing. I could not draw a human being. I could draw a whole lot of stuff, but I couldn't draw a human. I really enjoyed collaborating with him on this. Here is a case where I think I helped with the POV-Ray scene. These faucet handles really look to me like something I would have modeled, but the use of super ellipsoids for the mattresses and the sink, I think, were Alex's input. I got the perspective a little wrong with Ice Punk leaning against the wall here. It looks like he's sort of defying 3D space a little bit.
It makes it a little more surreal.
That concludes Era 2. From here on out, this was when I had my own computer that was Mac. This was a busy year for me. This is starting in January 2006. This was a project where Alex, Gabe, and I, we went into the backwoods and started taking pictures with the idea of putting them all together in a point-and-click adventure. And so we were like systematically taking 4 photos in each spot, looking in each of the cardinal directions. I was trying to get the effect of lightning outside, like it's a lightning storm outside this mansion, but it just ended up looking like bright moonlight. So this is another drawing that I turned into a POV-Ray scene. This was a character of mine named Quartz. Another situation where I composited onto a photo. I was like kind of enamored with this technique. This, yet another use of that tree macro, but this is also a height map. You can probably tell there's like a little bit of quantization going on here. Oh gosh, there's a story behind this. Alex was involved in this thing called the open source Game Boy game project. He created a Game Boy Advance game called Open Maze Advance, and then he retitled it to Nomad 2 Trapped. But there was I was heavily involved in creating artwork and for that game. One of the enemies was this thing that we were calling the Blade Monster. This is a sort of reimagining of it that I drew. I recreated the drawing in POV-Ray here, and this is like one of the first cases where I used radiosity. I started trying to develop a piece of software that I was calling key clocking, because the idea was it took the concept of keyframing and the POV-Ray feature of the clock variable. This was June 2006. I was 13. I created a bouncing ball in the back there and a pair of walking Lego legs. I was particularly proud of the walking Lego legs. Take a look at this.
That's pretty good for POV-Ray. Wow. The trampoline even bends in.
Let's see. Here are some more drawings that I made of my own original character, Ralk. In the top right here, he's fighting a Venus plant. But here it is in POV-Ray, not the Venus plant, just like my work, unfinished work on Ralk. I was using atmospheric media as sort of a unconventional technique to make what looked like very soft grass. This is like, I was like, let me just write a C program that generates POV-Ray geometry. This is a whole bunch of like different configurations, and I used it to make this scene. And I think in the final version, I added like some flames in using GIMP. This was December 2006. I was 13 years old at this point. This was a Christmas gift I made for someone the same year. For this one, I used, again, an unconventional technique here artistically, where I actually set the ambient light, I set that really high, and then I put some light sources in the scene with a negative brightness. So what I was going for was like sort of this electron microscope type look.
I don't think I've ever used a light source that was in a negative brightness.
And this I called Mobius Street, where I took two Mobius strips and like just sort of glued them together and reimagined them as a street for cars to drive on, just floating out in space. So I recreated this in POV-Ray, and was pretty proud of this too. One of the primary things I used here was the directives to make a loop. I like modeled a little tiny segment of the sidewalk and the asphalt, and then repeated that segment and slowly rotated it as it swept around in this circle. So here's the original POV-Ray render all by itself with no GIMP work on top. Here's just a little test animation that I made while I was designing that loop. Here is a POV-Ray scene I rendered I animated this using my key clocking software. There was an old video game. I think maybe it was on like DOS or something. It was called Cyberpuck. Okay, maybe I was just spelling it wrong. Yeah, okay.
Oh, yeah.
I decided to model it in POV-Ray, and I kind of wanted to make a whole animation of this. Like, this was 2007, May 2007. I was 14. I'm just going chronologically. This is the final thing I've got here. Like a pencil drawing a character to life.
Sure.
And on the pencil is printed all the tools I use as an artist to make this happen.
Okay.
Here was the POV-Ray render all by itself. And you can see the detail that I put into the pencil here. All right, well, that's it. That's all I got. Thanks for sticking with me.
Peter. Well, this was a fun trip down memory lane.
I just really, really appreciate all of the education that I received. You were a role model for me, you know? So I wanted this to serve not just as a chance for some of this old artwork to see the light of day, but also as a way to just celebrate that.
Well, thank you, Peter. It's been fun.
And now, all of the wonderful people in my audience can know where some of my greatness comes from my dad. That's what I meant when I said I had a CGI background. Moral of the story.
Yep. Those roots go back pretty far. Bye.